In question number 21, consider a transverse sinusoidal wave traveling on a homogeneous stretch string. If amplitude as well as frequency of the wave are doubled, keeping the tension in the string same, then the power transmitted becomes. So we know that the power transmitted P is equal to half of mu into V A square into omega square. So if the tension of the string will remain same, then P is proportional to A square into omega square. Since the amplitude and the frequency are doubled, omega is proportional to F. So this will be 2 into A square plus 2 into omega square. So this is proportional to 16th time of initial. So option 4 is the correct answer. Let's move to question number 22. In question number 22, a standing wave is produced in a string fixed at one end. The length of the string is L and amplitude of antinode is A. The string is vibrating in its first overtone with angular frequency omega. At t equal to 0, the antinode is at a distance √3a by 2 from the mean position in negative y direction and is moving towards the mean position as shown in the figure. Then the equation of the wave is. So since x equal to 0 is the point of node, so I can write the equation of the wave as y is equal to a sine kx into sine omega t plus phi. So at t equal to 0, the position of the antinode is this. So I can write at t equal to 0 minus √3a by 2 is equal to the amplitude of antinode is a into sine phi at t equal to 0. So from here the value of phi comes out to be 4 pi by 3 and 5 pi by 3. If I check the velocity of the point at the moment, so dy by dt, that is Vy, is equal to a into omega sine kx into cos omega t plus phi. Since the point is in the negative y direction and moving towards the mean position, so I can say that it is in the fourth quadrant. So the value of cos phi must be positive. In order to do that, phi must be equal to 5 pi by 3. So if I write the equation, then y is equal to a sine, and I have to substitute the value of k. Since the string is in first overtone, so I can say that L is equal to 3 times lambda by 4. So from here the value of lambda comes out to be 4L by 3. So the value of k is equal to 2 pi by lambda and the value of lambda is 4L by 3. So it is equal to 3 pi by 2L. So I'm substituting the value of k, 3 pi by 2L into x into sine omega t plus 5 pi by 3. So option 2 is the correct answer. Let's move to question number 23. Question number 23, the velocity of sound in air is 320 meter per second and density of air is 1.2 kilogram per meter cube. Then the pressure amplitude produced in air due to sound of loudness 120 decibels is. It is given that reference intensity I0 is equal to 10 raised to the power minus 12 watt per meter square. So we know that the loudness L is given by 10 into log 10 intensity I divided by reference intensity I0. The value of L is 120. So 120 is equal to 10 log to the base 10 I divided by I0, which is given 10 raised to the power minus 12. So on solving this, the value of I comes out to be 1 watt per meter square. Now we have to calculate the pressure amplitude. So delta P0 is given by under root 2 rho V into I. So on substituting the value of the variables, 2 into rho, that is 1.2 into V, that is 320 into 1. So on solving, it comes out to be 16 root 3 Pascal. So option 2 is the correct answer. Let's move to question number 24. In question number 24, a conductor of uniform resistivity is in the form of a cuboid. The side of length L of the conductor is along x-axis, the side of length B of the conductor is along y-axis, and the side of length H is along z-axis. If current through the conductor flows along x-axis, then its resistance is R1. If the current flows along y-axis, then its resistance is R2. So we have to calculate the ratio of R1 and R2. So if the current flows along the x-axis, then the resistance R1 can be written as R1 is equal to rho L, that is L divided by area, that is B into H. So if current is flow along y-axis, then the resistance R2 can be written as rho B divided by L into H. So if I take the ratio R1 by R2, it comes out to be L square by B square. So option 1 is the correct answer. Let's move to question number 25. In question number 25, the current sensitivity of a galvanometer is 0.1 milliampere per division. There are 50 divisions in the galvanometer. To convert it into a voltmeter of range 0 to 5 volt, a resistance of 980 ohm is to be connected in series with the galvanometer. Then the resistance of the galvanometer is. So we can say that V is equal to, that is the range of the voltmeter, is equal to capital IG, that is the maximum current through the galvanometer, into the resistance of galvanometer plus resistance of shunt. So it is given in the question 5. The value of IG can be written as 0.1 into 50, and this is in milliampere. So 10 to the power minus 3 in ampere. The value of Rg we have to calculate, and the value of shunt is 980. So on solving, the value of Rg comes out to be 20 ohm. So option 2 is the correct answer. Let's move to question number 26.